Okay, so yesterday we worked on projectile motion, the fundamentals of it, and then we did a couple of questions about horizontally projected projectiles. Okay, and I admitted to you yesterday at the end of class, there's only 3 ways I can ask a projected horizontally projectile question. Okay, and the first way was that I gave you the speed it goes off the cliff at, the height of the cliff, and ask you how far from the cliff it hits. Okay, the second way is that I can give you the speed it rolls off at and how far from the base of the cliff it hits, and I ask you for the height of the cliff. Or this way, where I give you the height of the cliff, how far it crashes, and ask you for the speed it went off at. Okay, that's what this one is about here. So what we have is a ball that rolls off of a table. So it's going to do this. Okay, it's going to follow that arc that we saw yesterday. We know that vertically speaking, it is going to fall 1.2 meters because that's how high the table is. Okay, horizontally speaking, okay, we know that it hits the floor 0.85 meters from the table. Okay, so that's its horizontal displacement. Okay, what speed did it roll off at? Well, it rolled off horizontally. So what I'm looking for here is the horizontal velocity. What do I need? I need the time. Okay, what other pieces of vertical information do I have that are not explicitly stated?
Gravity.
Gravity, right. And what's the other one?
V1
Yeah, VI. And VI is? 0, because it rolled horizontally off the table. It wasn't moving vertically at time 0. All right, if I have those 3 pieces of information, I should be able to find the time. Have we had to find the time in every projectile question we've done so far? Because it's the one thing that can go on both sides, right? It's the one thing the horizontal and vertical parts share. Okay, so we are going to be looking at d equals vi times t plus 1/2 at squared. Okay, we want to get rid of this. Vi is 0, so we can. We're solving for t, so we'll divide both sides by half of a and square root that to get t. So t will equal the square root of 1.2 meters, the vertical displacement, divided by 1/2 times the vertical acceleration, 9.81 meters per second squared. Okay, and I forgot to fire up my calculator. What did that come out to, guys?
4.5.
What is it?
4.5.
That seems really big. Did you forget square root?
Oh wait, yeah.
Okay, so square root of 1.2 divided by 0.5 times 9.81. Okay, so 0.49 seconds. Takes half a second for it to fall to the ground. All right, now that I have the time, now I can bring that over here. Okay, and I can use it to calculate V. V equals d over t. 0.85 divided by the 0.49, obviously with all the decimals, okay, for significant digit rules here. Okay, so it rolled off the table at 1.7 meters per second. Okay, is that ringing a bell from yesterday? Okay, what we're going to look at today are the other type of projectile motion question. Okay, and those are the ones where the projectile is fired at an angle or launched at an angle initially. So in that situation, will the vertical initial velocity be 0? It will not. If you launch something at an angle, it's got some initial vertical velocity to it. VI will not be 0. In these types of questions, you will have to do a little bit of vector components. Okay? Not vector addition, you don't have to draw vectors tail to head, but your projected velocity, the velocity the projectile is fired at, is your vector. And you will have to calculate its vertical component and its horizontal component. Those will be your 2 speeds, okay? Or sorry, velocities, okay? That'll be your initial vertical velocity and your horizontal velocity. Okay, so let's have a look at, so let's say we're doing this question here. Okay, I will quickly show you the clip of the jump, okay, and then we'll. Okay, so in a question like this, we're not driving off a cliff this time, okay? We're jumping off of an incline, which changes how the question sets up. What we have instead is this, okay? This is our projected or launch velocity. Okay? In this question, we're told that that velocity is 32 meters per second. So I know the length of this vector is 32 meters per second, and it is angled 20 degrees above the horizontal. Okay. Now, as we watched the car fly through the air across this river, okay, it did this. And it came down to the ground over here. We're going to assume that where it landed and where it launched from are level. Okay? In that particular shot, that's probably not true, but we're just going to say that it was. Okay? It launched from one side of the river, landed on the other side of the river, and they're the same height. Okay? Now, does this car move both vertically and horizontally as it travels across the river? Right? It goes up and comes back down and travels horizontal. Just like in the other type of projectile motion question, the vertical part is accelerated because of gravity, and the horizontal part is a constant velocity because there's no forces acting on the car horizontally once it launches. There's no air resistance or anything like that. So we set it up very similar to how we set up the last kind. We would break it up into its vertical and horizontal components. Okay, now they only gave us this. That's it. Okay, they gave us the context of the question, and they said, here's the velocity it launched at. And then it expects us to get the distance across the river. Would that be horizontal or vertical? Distance across the river, horizontal or vertical? Horizontal. Okay, that'll be it. So they want us to calculate the horizontal distance. Okay, so that's one of the things we have to get. Okay, in order to get that, I'm probably going to need time. And they want to know the maximum height. It says how high above it does the general fly. Okay, so we would be looking for the vertical maximum displacement, okay, which is different than the total vertical displacement. In this question, if it launches from here and lands here, what's its vertical displacement over the whole trip? You're right. Zero, right? Its launch height and landing height are the same height, so it has no vertical displacement over the whole trip. Okay? Its maximum height actually occurs right smack in the middle. Okay? So if I was actually just watching the vertical part of this motion, okay, so let's say I was like standing behind a car when it jumped, all I would see is a car going up and a car coming back down. That's all it does from a vertical perspective. Okay? If I'm watching it from the side, I see both, right? But if I'm watching it from behind, or well, I wouldn't want to stand in front of it, but okay, if I was watching it from behind, okay, all I would see is the vertical part of the car going up and coming back down. No different than if I just threw something up in the air. Okay? The vertical part of any projectile's motion is exactly the same as if you just throw something up in the air. Okay? So, if I know this projected velocity, could I find its horizontal component and its vertical component? Okay? If I find its horizontal component, this is a velocity. So its horizontal component is also a velocity directed horizontally. Would that give me one more piece of horizontal information? It would. Okay? The reason I'm kind of slowing this down, guys, is I want you to understand what we're calculating when we find these two components. Okay, we're finding its horizontal constant velocity when we find the red line. So let's find that first. Okay, so that's going to be the horizontal velocity, which is constant throughout the entire flight of the car. Okay, how do I find the red line?
I put in 32 times cos of, or cos of 20.
Exactly, yeah. Use trigonometry. That's the adjacent side to the hypotenuse and to the angle. Okay, so yeah, I would go cos of 20 degrees times 32 meters per second. That will tell me the horizontal component of the launch velocity. All right, so cos of 20 times 32. Okay, so the General Lee is flying through the air horizontally at a constant velocity of 30.07 meters per second. Okay, that's well over 100 kilometers an hour. If I find the vertical component, what am I finding? Does the velocity vertically change as the General flies through the air?
VI.
You're finding VI. The answer is yes, it does change as the General flies through the air, because if I'm just watching its vertical component, I'm seeing an object going up slower and slower and slower, and then coming back down faster and faster and faster. Okay? Its vertical velocity is always changing through the flight. When I calculate this is its initial vertical velocity. It's how fast it was going at the instant it was launched. Okay, so that makes it its initial vertical velocity. So this side will be VI vertical. Okay, now that's the opposite side. So I would go sine of 20 times 32 meters per second. Okay, just finding the Y component here. Okay, so vertically speaking, it launches at an initial vertical velocity of just under 11 meters per second. Okay, 10.94 meters per second. And I'm going to make that positive because it's moving up, right? It was launched at an upward angle. Okay. What goes up must come down. If the vertical part of that motion is identical, or mirror image, let's say, okay, of each other, and it launched at 10.94 meters per second up, how fast is it going when it crashes into the ground on the other side? (10.94). Okay, remember, the acceleration is the same, 9.81. So when it launches, it's going 10.94 meters per second up. Up it goes, slows down, slows down, slows down, okay? Comes to a stop for an instant at its maximum height, and then falls back down the exact same distance at the exact same rate of acceleration. It has to be going exactly the same speed it left at when it comes back down, because these two things are mirror images of each other. Okay, so that's just something we have to understand. Okay, that if the launch and impact points are level, the initial and final velocities are equal.
Is the final velocity 0 though when it hits?
No, that's after. That would be a separate acceleration because it has to slow down, right? When it hits the ground, it's not going 0. The ground slows it down to a stop rather violently.
Okay, I
Yeah,
see.
we don't include that as part of it. But that's a common misconception. I get a lot of people saying, well, the car died. It's 0 now. Like, yes, it's 0, but it's 0 after it hits the ground. There's a separate acceleration that stops it. Okay, so what we have to understand about at least this situation and most situations that we're going to deal with, okay, VI and VF are equal in magnitude, but opposite in direction. Okay, what else do I know vertically? One more thing.
Acceleration.
I know the acceleration, okay? It's gravity. Do I need to make gravity negative here? I do. Okay. I'm trying to find the horizontal distance, and I have the horizontal velocity. We established earlier that if I want to get that horizontal distance, what I need is time. Can I find it over here? I have VI, VF, and A. Can I find T? Can I use last year's acceleration formula for that? Absolutely. Okay, so if I want to find what T equals, I'm just going to use this formula that we learned in Science 10. Okay, A equals VF minus VI over T. Okay, so we solve for T. T will be VF minus VI over A. Okay, and that's going to be negative 10.94 with all the decimals minus 10.94 divided by negative 9.81 meters per second squared. Okay, have you used that formula a lot? Between last year and this year? Yes, you have. Okay, so let's calculate the hang time of the car. Okay, so I'm going to take that number, I'm going to go negative that number, and I'm going to subtract that number. Okay, and then I'm going to divide that by negative 9.81. Okay, car is in the air for 2.23 seconds. That is a long time, but it was a pretty long yee-haw as well, okay, as they went through the air, because that's what they always said in that show, every time they jumped the car. Okay. All right, so we've got 2.23 seconds. We'll keep all the decimals. Where can that time go now? It's the one thing they share. Okay, time is the one thing they share. Okay, can I calculate the horizontal distance traveled now? I got V, I got T, I think so. Okay. D equals V times T, so 30.07 times 2.23. Is that exactly what we did yesterday with those projected horizontally questions? It's exactly the same thing. Okay? The fundamentals are the same here. I need the time, I can use the time here, okay? So, how far is it across the river? $67 meters. To give you perspective, that would be if a car jumped from the starting line on the track, way over there, to about 15 meters past the gate over here. Okay? It's a long way to fly a car through the air, especially since they don't have wings. Okay? So you know you're just going to come crashing down at the end. Okay? All right. That was the first thing they wanted us to find, the horizontal distance. They also wanted us to calculate the maximum height that the car would reach. Okay, so let's go back to this. We can still keep all of this work that we've done. It's still going to be useful to us, okay? The maximum height occurs here, exactly halfway through the flight, okay? Vertically speaking, how fast is the car going at its maximum height? If I throw something up in the air, it slows down, slows down, slows down. How fast is it going at its maximum height? 0. Because that's where it stops for a second and turns around and falls back down. Anytime you throw something up in the air, there's an instant where it stopped at its maximum height. So what I have to understand is, in terms of time, the maximum height occurs halfway. So it would be at half of 2.23 seconds. That its vertical velocity at its maximum height would be 0 meters per second. Okay? Everything else I can keep. I can still keep VI. I can still keep acceleration. Okay? I have to remember to split my time in half if I want to use it, because this occurs halfway through the trip instead of all the way through. Okay? But as long as I remember those things, there's actually more than one way for me to calculate the vertical displacement at that point. Okay? This is just an acceleration problem. Here are the things we have. We have VF. We have VI. We have acceleration. And we have time. So it would be 1.115 or something like that. Seconds, something along this, half of 2.23. Okay, everybody okay with that? Okay. Calculate the displacement then. Okay, those are your givens. There's more than one way to do this. Okay, I'll actually put the real time up there instead of that number, which could be wrong. .156. Okay, two choices here. Both equally valid, both will arrive at exactly the same answer. Okay, I could use this formula, D equals VI times T plus 1/2 AT squared. The advantage of that formula is I don't have to do any algebra. It's already set up to calculate D. The disadvantage of that formula, you have to remember to divide the total time by 2. I would say more than 2/3 of people forget that when they use that formula. Okay, in my experience. Okay, people go to that formula, but they use the total time, and they don't get the right answer because they forget. They have to use half the time. The maximum height occurs halfway through. If we use this with half the time, it works great. Okay, we'll have our 10.94 times 1.156 seconds, okay, plus 1/2 times negative 9.81, that's crucial, times 1.156 squared. Okay, so if I put that in with all the correct decimal places and everything, okay, so I'll take my 10.94 here, okay, multiply that by 1.15, add that to 0.5 times negative 9.81 times that squared. Okay, I'm going to get that the maximum height reached by the car is 6.1 meters. We have two significant digits there. Okay, so the maximum height is 6.1 meters. Okay, that's one of two equally valid ways to solve that problem. Here's the other choice. I can use this formula. Okay? I have to remember that VF is 0. And I also have to remember, okay, that, oh, I just drew it. You ever had that happen? Where you were like, you had this train of thought, and then it just disappears from your mind? Oh, I have to remember that it's 0, but I have to include it. I can't just get rid of it. I have to keep it in there. That's what my train of thought was. Okay, so I'm solving for D here, so I do have to do a little bit of algebra. Okay, I'm going to have VF squared, which is 0, okay, minus VI squared divided by 2A equals D. Okay, and this will work and give me exactly the same answer. Okay, I'll have 0 squared minus 10.94 squared divided by 2 times negative 9.81. So 0 minus 10.94 squared, okay, divided by 2 times negative 9.81. It is exactly the same number as it should be. Okay? Just two different ways to go about calculating the same thing. Right? So either way, on a quiz or a test, would be valid. You can choose whichever formula you like. I like the second one, because then I never forget to divide the time by 2. All right, that is a very typical projected at an angle question. Those would be the things I would ask you to do on a quiz or a test. Okay? Calculate the horizontal distance traveled for which you would need the time and the maximum height of the object. Okay? Pretty typical question. All right. Okay, and you're being given the launch velocity, magnitude and direction. Okay, so you can kind of refer back to your first example. Okay, if you get stuck, and let's see how we do on this one. Okay, for another example of that.